this one, we're going to find the area of a hexagonal pyramid. So you can see our base has a hexagon that has a height of 10 and an apothem of 4 root 3. So you can see that the height from the apex to the base is 10. Now the apothem is going to be 4 root 3. The apothem is the distance from the center to the side here. So here, right here, this part is going to be 4 root 3. So to find the surface area, we want to know what the perimeter of the base is, we want to know what the slant height is, and we want to know what the area of the base is. So right now, unfortunately, we actually don't have any of that information. We can go ahead and try to figure out what that all is, though. So let's go ahead and draw in the triangles here inside of our base. This, since it's a hexagon, that purple triangle here is going to be an equilateral triangle. So if this apothem here is 4 root 3, that means we have a 60-degree angle and a 30-degree angle. So what we can do is we can go ahead and use our 30, 60, 90 triangle, and our side length down here then would be 4, because across from the 60 is the n root 3, and across from the 30 is the n. What that does for us is if we double it here, we know that each edge here along the base is going to end up being 8. And so therefore, we can end up finding out that our perimeter here should be 48. We also now can find the area of the base. We can look at this and say the area of this triangle here is 1/2 the base of the triangle times the height of the triangle. So each triangle here would be 16 root 3, and in our base here, there's going to end up being 6 of them. So the area of the base then is going to end up being 96 root 3 because of that. So then the trick is, how do we find the slant height? So our slant height is the distance from the apex down to the side of the base here. So we need to know what that red mark is there. So we have a right triangle we can draw in here. We know that the height of that red triangle here is 10 because the height of the pyramid is 10. We also know one of the other sides. This side along the bottom here, that is actually going to be the apothem. So that's going to be 4 root 3. So then what that allows us to do is to do the Pythagorean theorem in order to find that slant height here. So we're going to do 4 root 3 quantity squared plus 10 quantity squared equals L squared. And so you do your Pythagorean theorem, we end up with the square root of 148, which then simplifies down to 2 root 37. And so now what we're going to do is we're going to go ahead and plug everything into our formula. So our total surface area is going to end up being 1/2 the perimeter of the base, which is 48, times the slant height, which is 2 root 37, plus the area of the base, which is 96 root 3. After we've done all of that, then what we can do is we can just simplify things to get our overall surface area to be 48 root 37 plus 96 root 3 inches squared. Okay, so then our last example here, we want to find the surface area and the volume of this shape. So we have a cylinder here, and we have this cone that's kind of drilled out of the cylinder. So if we wanted to find the surface area, let's go ahead and just start with our surface area. Let's go ahead and figure out the parts that we want for the surface area. So the first thing that I notice is I want this circle on the bottom here. So we want the area of the base. Then we also kind of want this distance around the cylinder. That is going to be the lateral area of the cylinder. But then we also want the area around this part that's kind of drilled out here, the lateral area of the cone. So if we were to add the area of the base plus the lateral area of the cylinder plus the lateral area of the cone, we then would have our total surface area. So let's go ahead and start finding what all of those then would be. So the area of the base here, since our base is a circle, it's going to be pi r squared. And our radius here is going to end up being 10 because the diameter of the circle is 20. Then we want to find the lateral area of the cylinder. So the lateral area of the cylinder is going to be the perimeter of the circle times the height. Now we need to be able to actually find the height of the cylinder. We don't know what this is. We know this part here is 10. We don't know what the height of the cone is. That's more of our problem here. So what we can do is we can draw in a triangle up top here. And since the radius of the bottom should match the radius of the top because the circles are congruent, this should be 10. And so what we can do is we can do the Pythagorean theorem. So 10 squared plus our height squared equals 26 squared. And we can find our height to be 24. Which means that the height of the entire cylinder then is going to end up being 36. So to find the lateral area of the cylinder, we're going to do 2 times the radius times the height times pi. So that's the circumference times the height. Now we also want to find the area of the lateral area of the cone. So the lateral area of the cone is going to be pi r L. And our slant height is actually that 26 for this one. And so now looking at this, we're going to go ahead and figure out what each of those are and then add them all together. So you can go ahead and calculate that. You're going to end up with 1040 pi units squared for your surface area. For your volume, it's actually going to be a little bit nicer to calculate because you really only need to do 2 things for your volume. We need the volume of the cylinder minus the volume of the cone. So the volume of the cylinder is going to be pi r squared times the height, and the volume of the cone is going to be 1/3 pi r squared times the height of the cone, which is 24. And so if you were to take and go ahead and simplify all of those and figure out what that is, that's going to end up being 2,600 pi units cubed for your volume. Thank you very much for listening, and I hope it helped. Bye.